All right, as we get started today, open up your textbooks if you would, page 28. I want to quickly review what we've been talking about these last few lessons. We've talked about division, and of course we talked about monomial division and polynomial division and synthetic division and even division by inspection. And then we talked about division under another name. We're not calling it division anymore, but that's really what it is. Kendall's back with us. Kendall, what have we been talking about these last couple of lessons?
Synthetic.
Well, yeah. Anyone? Factoring. Factoring is what we've been working on. We call it the name factoring, but it really is a form of division. And we said the first thing we always check for when we factor, Genesis. You got the idea behind it. Common factor. We always check for a common factor first. And we looked at common monomial factors and even a little bit of common binomial factors. We'll revisit that idea later. We then looked at factoring a perfect square trinomial. And we said that a perfect square trinomial, Maddie, will factor into binomial squared. We said that a difference of squares will factor, Genesis, into a sum and difference. But what did we say about a sum of squares? I told you to write something down about a sum of squares. It does not factor. And so we looked at some difference of squares. In fact, we looked at one that factored into a sum and difference. Both of them, a sum of squares, difference of squares, factored again. Difference of squares, but not the sum of squares. You're on page 28. Look at number 15. And that looks like a perfect square trinomial. And there's 4 reasons why it looks like a PST. Noah, what is it about number 15 that makes it look like a perfect square trinomial? Good. Perfect square at the beginning, perfect square at the end, positive last term, even middle term. If it is a PST, class, we said it'll factor into a binomial squared. What would the binomial squared be, Noah? Doing it in our heads. Good. X negative 4, quantity squared. What about number 20? Number 20, another perfect square trinomial. What would we factor that into, Michael?
3x negative 4.
Quantity squared. Not just 3x negative, if you forget the square, then you lose points and it's sad. 3x negative 4 quantity squared. What about number 26? What would we get if we factored that? Back to Kendall.
2a squared negative c.
There we go. 2a squared negative c, quantity squared. So we can see that these are very easy to factor very quickly, as long as there's not a common factor in the way first. But if there is, factor it out and go from there. We then looked at, of course, the difference of squares. And we look at number 34. We have a perfect square minus a perfect square. That's the difference of squares. In class, we said that'll factor into a sum and difference. So instead of one binomial, we said we're going to have 2. One binomial is going to have a plus. One's going to have a minus. What would the sum and difference look like on 34, doing it in your head, Abby?
9x plus 13 times quantity 9x minus 13.
Good, the quantity of 9x plus 13 times the quantity 9x minus 13. Drop down to number 35. It is a difference of squares, but I shouldn't factor it into a sum and difference yet. Raise of hands. Why not? Why not? Audrey? Good. We should pull out the 9 first. And Audrey, what do we get after we factor out the 9? Good. And notice it's still a difference of squares. So if it starts as a difference of squares and you realize there's a common factor, you're not going to lose out on anything. Pull out the common factor. You're still going to have the difference of squares. And now this difference of squares factors into a sum and difference. And what would that be, Genesis? There we go, a squared plus 3b and a squared minus 3b, but this is not my answer. Why not? Make sure we bring down that common factor. Now, don't lose the common factor. Looking at number 36. Is there a common factor in 36? Michael?
No.
No, nothing common that we can factor out, but it's a difference of squares, so class, it'll factor into a sum and difference. Michael, doing it in our heads, what would we get for 36?
It would take me a while.
It would. What's the square root of 64?
8.
Okay, and then the square root of c to the 4th, just cut it in half. Okay, and then that's going to go before the pluses and minuses, right?
Yeah.
So think we've got it. Now, what's our answer?
8c squared plus and minus 9r.
Good. 8c squared plus 9r, 8c squared minus 9r. And again, these are things we can factor in our heads working very quickly. 41, though, is a little bit different. Do this with me there at your seats. Go and write down the problem, first of all, there in your notebooks. We got the 3g negative 2 quantity squared minus 16k squared. And it is a perfect square minus a perfect square. So it's a difference of squares. And a difference of squares, class, factors into a sum and difference. So we're going to set up two sets of parentheses. We're going to put a plus in one of them. We're going to put a minus in the other one. What's going to go in front of the plus and minus, Maddie? 3g negative 2 in front of the pluses and minuses. And then after the plus and minus, we'll put 4k. And here, our sum and difference looks like a pair of trinomial conjugates, and they are, but we'll just leave it just like this. Now, technically, one could argue, shouldn't you keep the parentheses around this? Well, initially, yes, but what sign goes in front of these parentheses, class? A positive, in both cases, right? So the parentheses just fall off anyway. But I want you to look at this one, if you will. Copy this down on your paper. X squared minus the quantity 3x plus 4 quantity squared. X squared minus the quantity 3x plus 4 quantity squared. Here, again, difference of squares, right? Sum and difference. But here, you're going to have a plus before one of the sets of parentheses and a minus before the other. So I'm going to suggest that when we take the square, obviously, square root of x squared, class, x. So x goes in front of the plus and minus. After the plus and minus, initially keep the parentheses around your 3x positive 4. You're doing this with me. Then remove the parentheses. Here, parentheses preceded by a positive. So, thoughts, class? Just take them off. And we just get x plus 3x plus 4. But here preceded by the negative, what do I have to do to both signs in here, class? Change them. Distribute the negative, if you will. So negative times 3x, class, negative 3x, and negative times a positive 4. Negative 4, you could just say change the signs. They were both positives, change them both to negatives. But I'm still not done. Noah, why not? Genesis, do you see why I am not finished yet? Anyone? Michael?
The both x.
I can combine like terms still, can't I? Again, the goal is to simplify as much as we can, right? So x and 3x should combine, class, to give us a 4x, positive 4. And the x and negative 3x, negative 2x, negative 4. And you know what? I'm still not done. Because by combining like terms, do you see what I created in here? A common factor. And in here, I've got a common factor. So again, working this with me, the first set of parentheses, class, my common factor is 4. So I can pull out a 4, and that'll leave me with, in parentheses, what, Kendall?
X plus 4.
Good. What about in the second set of parentheses? What's the common monomial factor here, anyone? Negative 2. If there's a negative first term, factor the negative with the number. So not a 2, but a negative 2. Now be careful. Factoring is division, so I'm dividing here and I'm dividing here with the negative 2. What goes in the parentheses, Noah? X plus 2. Now, one final detail for you to note. I don't know if you want to write this statement out, but if you have monomials, multiple monomials, combine them into one single monomial factor at the beginning. So the 4 times negative 2, class, gives me, I'm going to write the negative 8 at the beginning, then the x positive 1, then the x positive 2, and this is my fully factored form. Okay, so monomials we're going to combine to a single term at the beginning. So if this were like a 4a and like a negative 2b, we get negative 8ab, all as one single monomial at the beginning. Does that make sense? Okay, so a couple weird things happened here. The ability to combine terms, a late appearing common factor, having a couple of common factors to combine, having to factor out a negative common factor. A lot happened in this example. Questions on this? Questions here. Let's do another one somewhat similar to this. Write this one down now if you would. A positive 2b quantity squared minus 3a negative b quantity squared. a positive 2b, quantity squared, minus 3a negative b, quantity squared. Well, I have a perfect square minus another perfect square. Class, we call this call it what? Difference of squares, right? Minus sign, squares, difference of squares. Now, if I were to square the binomials, yes, I would get perfect square trinomials. I'm not going to do that. I'm factoring, not multiplying. So I'm going to get, from my difference of squares, that's I'm going to factor that into a sum and difference. Going to get a plus, going to get a minus. What goes in front of the plus and in front of the minus? Genesis? If this said x squared minus y squared, what would I put in front of the plus and minus here? X and x, right? Whatever's being squared, I put once here and the other second time there, right? So since it's an a plus 2b squared, I should put, and there we go, put a plus 2b. Technically in parentheses, but again, we understand both of these parentheses are preceded by positives. They're just going to fall off. After the plus and minus, Genesis, I should put 3a minus b. Just as if it were y squared, I'd say put y and y. It's 3a minus b squared. So put quantity 3a negative b and quantity 3a negative b. Now here, once again, we're preceded by the positive. So here, once again, class, the parentheses can just fall off. But here, because the parentheses are preceded by a negative, class, I've got to change the signs. I'm going to change my 3a into a negative 3a. I'm going to change the b into a positive b, and that's going to allow the parentheses to fall off. From here, let's combine some like terms now that the parentheses are gone. Maybe it'd be a little easier if we literally saw them gone. All right, what do we get when we combine like terms now? Let's go back to Abby.
I don't know.
Well, a and 3a combine, right?
Oh, I was confused on the other one because I wasn't thinking that. I was thinking something else. But, positive 4a, positive b.
And then in the other set of parentheses,
Negative 2a, positive 3b.
Now, one thing I want to point out here, notice there is no common factor to pull out. There isn't a common factor, but there is still a leading negative. So I've got two options here. Option one is to factor out the negative. But remember, we said our monomial is going to come all the way to the front anyway, right? So let's factor out a negative 1, but I'm going to be too lazy to write the 1. I'm just going to say negative. I'm going to leave my 4a plus b alone. I'm not messing with that. I'm pulling a negative all the way to the front out, which changes this to a positive 2a divided by negative 1, and gives me a negative 3b. That's option number 1. This is one way to write your answer. The other way, the whole problem is I've got a first term negative. Not allowed to have that. That's not negative. Why don't we just flip-flop? Make sense? So if I had, for instance, 4a positive b times 3b negative 2a, now I don't have to factor out a negative. I got a first term positive. So two different ways to approach it. Some people would argue this is better because you keep the a's first, then the b's. The separate terms really doesn't matter. Keeps the binomials similar. Okay, great. I'm done with the problem anyway, though. So I got no problem with the flip-flop, but this method works as well. Questions on this? Hand down, Michael. Questions on this? All right. I think we got one more that I want to have you work on here. Write this one down. Negative 8a squared b, positive 8ab, negative 2b. Negative 8a squared b, positive 8ab, negative 2b. This is not a difference, or a difference of squares, right? For one thing, it's not a binomial. It's a trinomial. Is it a perfect square trinomial, class? Not right now, right? Not perfect square, not perfect square, not positive. It's even middle term, I guess. But we need all four to check out. But what's the first thing I always check for when I factor, Kendall?
Common factor.
Common factor. What's common to every single term, Kendall?
2 and a b.
A 2 and a b. And class, because the first term is negative, and you ain't allowed to have a first term negative, I'm not just going to factor out the 2b but a negative 2b. Doing this with me. If the first term is negative, factor out the negative. What's left when I factor out the negative 2b here? Kendall?
4a squared negative 4a, and then positive 3. No, positive 1.
Positive 1, because everything cancels when we divide it there. Questions on this? And now, perfect square, positive even. I have the perfect square trinomial. Which class factors into a? Binomial squared. Thank you, Audrey. So what is the binomial? Don't forget the squared. And what is the binomial going to be, class?
4a minus 1.
Ooh.
Oh, 2a.
2a minus 1. There we go. Take the square root of that first term. And there's our answer, factored up. Questions on these different factoring things? There's just a few weird things that didn't really come up much at all, if at all, in Algebra 1. I wanted to point them out to you now. Questions on this? With factoring out negatives and combining terms potentially and factoring out later on, finding common factors that weren't there at the beginning. Questions on this kind of stuff? Or we feel like we understand? Let me give you some classwork then to give you a chance to practice with these. Put some more up in just a moment. Start with this one, and then I'll put up some more in a moment. 12 x cubed yz. Negative 15 xy squared. Positive 6 x to the 4th y cubed z squared. Factoring that. While you're doing that, I'll put up more. Chemistry. Reactions. Shake up a bunch of protons and electrons, and it turns pink. Don't tell Miss Morris, she would be ashamed. My very vague explanation. Was to keep me from catching what Kendall had. I didn't pick on you very much while you were gone. Right? Just on random all the time. What's the square root of 400, class? 20. 20. All right, pencils down even if you're not finished. Your answers to the first four should have been fairly straightforward. We're just pulling out a common factor, turning a PST into a binomial squared. Then this one was a little weird, right? We could pull out the negative, keep that -1, if you will, and turn the difference of squares into a sum of difference. Or if you just flip-flop them, that takes care of your first term negative problem. And you still have a difference of squares, factor in a sum of difference. Notice these are identical binomials, right? Yeah, it's just commutative property. And then here, these are exact inverses, but that's where the negative comes in. The negative turns that negative and turns that positive. So that's why these two are exactly equal. And then on this one here, pretty straightforward. Remember that when you take the square root, you cut the exponent in half. So just like here, we went x to the 6th square root is x cubed. B to the 10th square root is b to the 5th. And we'll put that both places. How many good on the first four? You got the first four all correct. All right, questions on the first four? Questions on the first four? All right, let's take a look at this one here. What is this thing, class? Difference of squares. And difference of squares factors into a sum and difference. So we set up our two big old sets of parentheses with the plus and the minus. What goes in front of the plus and minus, Maddie? 3x negative 2y. We've understood positives before. I'm not going to write the parentheses. And after the plus and minus, Abby?
2x minus 5y.
I'm not going to put the parentheses here because it's after a positive. And here, instead of putting the parentheses and then removing them, I'm going to change the signs. Instead of a positive 2x class, I'm going to use this minus here as my negative 2x. And then instead of a negative 5y, positive 5y. Okay, so that's how the lazy man kind of navigates quickly. From here, we just need to combine some like terms, Kendall.
5x negative 7y, and then 5x, no, 1x positive 3y.
And there's that. How many got this for the last one? And we'll get all the way to the end and finish it correctly. Good, several of you. Questions on that last one? Questions on that? Any questions on the factoring we've covered so far? So for those on the watching, we're working our way through different factoring methods. We see that the common monomial factor was what we talked about first, then the perfect square trinomial, then difference of squares. These are our big three. These are the most common three. These are the three you learned last year or 2 years ago for some of you. Questions on these? All right. Next section in your notes. Next section in your notes. Don't write anything yet. I just want you to watch and consider something here. Actually, do write this down if you would. C cubed minus D cubed. C cubed minus D cubed over C minus D. C cubed minus D cubed over C minus D. This should look familiar to you. It's division by inspection, right? Binomial divided by binomial, where these match, those match, right? And for a difference divided by a difference, even, odd exponents doesn't really matter, and all my signs are going to be positive. So when we divide, I get 1 power less, so class C squared, then the D starts out as gone, then, and we said all the signs are positive, right? If that's true, if this divided by this equals that, then this equals this times that, correct? So that c cubed minus d cubed is equal to c minus d times c squared plus cd plus d squared, right? Write this one down. M cubed plus n cubed divided by m plus n. M cubed plus n cubed divided by m plus n. Same thing, right? Division by inspection, except for a sum divided by a sum, you can't just make up whatever exponent you want and have it work out evenly, class. For a sum and a sum, the exponents have to be... For a sum and a sum, the exponents have to be odd. Okay, we're actually covered here. Okay, so cube and cube were odd, okay? But the signs are going to alternate. So again, it's going to be the m squared, m to the first, m gone, n to the first, n squared. Signs alternate. First term's always positive, which we can leave understood. Then positive. Well, again, if this divided by this equals that, then this times that is equal to this, right? So then write this down. M cubed plus n cubed is equal to m plus n times m squared minus mn plus n squared. Notice if you have a difference of cubes or a sum of cubes. Either way, you get a binomial times a trinomial. And that's our next section. Write that in your notes. A sum or difference of cubes, a sum or difference of cubes becomes a binomial times a trinomial. Using a little shorthand here. A sum or difference of cubes becomes a binomial times a trinomial. Something I want you to notice about the binomial. Notice, if it's a difference of cubes, the binomial is a difference. If it's a sum of cubes, the binomial is a sum. Okay? So I want you to note about the binomial, it's going to have the same sign as the problem, or same sign as the original, maybe, would be one way to say it. Same sign as the original. If that's true, then a difference will end up being factored into a difference and a whole bunch of positives, right? Whereas if it's a sum, it's going to factor into a sum and alternating signs, right? So, if negative, then all positive here in the trinomial. But if a positive in the binomial, we're going to get alternating signs in the trinomial. Okay, so if it's a negative in that binomial, we end up with all positives here in the trinomial. If it's a positive, then we end up with alternating signs. One more thing I want you to note about this trinomial. There will be times, depending on the sum or difference of cubes we're factoring, that you'll end up with perfect square, positive. Now here we don't have it even, but there will be times you'll have it. It will never be a PST. Okay? It'll look like it sometimes. But I want you right now in your notes to just remind yourself this is never a PST. And that's a good thing. Because if it were a PST, guess what you'd have to do? Factor it into a binomial squared, but you don't have to. You're off the hook. Okay? So that just means you get to be a little lazier. So that's a good thing, right? We all like being lazy? Agree? All right? If not, you're not a true mathematician. I have not converted you yet. But yeah, it's never going to be a PST. Even if it looks like it, don't worry about it. We're done once we get our binomial times the trinomial. All right, let's have you try one of these. Let's take an x cubed minus y cubed. Notice it is a difference of cubes. How do we know? I have a minus sign and cubes on either side. Okay? Difference of cubes. And a difference of cubes, class, factors into a binomial times a trinomial. Okay, one more time. Sum or difference of cubes, in this case difference of cubes, factors into a So set up a little set of parentheses and a little bit bigger set of parentheses. Okay? Instead of the sum and difference where you do two sets of parentheses, well, it's going to be little parentheses and bigger parentheses. Make sense? Mm-hmm. All right, what's going to go in the little parentheses? It's going to be a binomial that looks just like what we had here, but except not the cubes. So basically, if you want to think of it, take the cubes off, and you got your binomial. So class, we're going to write x minus y. And because we have a minus, what's going to be true of the signs in here?
Positive.
All positives. We're going to still start one power less. So we're going to start, then gone. Then the y is gone, y, and we said all signs positive. And we're done factoring. Seem easy enough? Now, not something we learned in Algebra 1. This is not review for anybody, I don't think. I mean, unless you went to another school and learned this in Algebra 1. But for all of us now, this is new, where we've been reviewing primarily questions. Write this one down. C cubed, positive 27. Strategy tip. Rewrite so you can literally see the cubes. As in, something cubed plus or minus something cubed. It doesn't say that right now. It says c cubed minus 27. How could I rewrite this so that I get something cubed right here, class? 3 cubed, right? It's c cubed plus 3 cubed. That makes it easier for you to see your binomial when you get ready to do the binomial trinomial, right? Well, it's right there in front of you. Just take the cubes off, class. What's your binomial? C plus 3. Now, to be fair, could you get that step without showing this? Maybe, but you know what? It doesn't take that much longer to write it down, and this will keep you straight. If you'll take the time to rewrite as something cubed plus or minus something cubed, there's your binomial. Now for my trinomial, I'm going to start with c squared, then c, then gone. I'm going to start with the 3 as being gone, then 3, then 3 squared or 9. And the signs, because I have a sum right here, my signs are going to, the first term is always positive, then, and I'm done. All right, questions on this? Feel like we got this? Getting it at least? Okay, I saw some books on my face. Not quite got it, but getting it. How about this? Write this one down. R to the 6th plus S to the 6th. Now remember what I told you. All even powers are squares. This is a sum of squares. But it's also a sum of cubes. Because all multiples of 3 are cubes, right? Say them with me. 3, 6, 9, 12, 15, 18, 20. Well, you get all of those powers are cubes. So if I try to treat this as squares, I look at this, well, that's a sum of squares. You can't factor a sum of squares. But you could rewrite this as a sum of cubes. Michael, what cubed?
R squared.
R squared cubed plus
S squared.
S squared cubed. So it is a sum of cubes. I can't factor a sum of squares, but because it's also a sum of cubes, I can factor it that way. And a sum or difference of cubes class factors into a binomial times a trinomial. So my binomial here is going to be what, Noah?
R squared plus S squared.
Good. If you'll strip the cubes off, you'll see your binomial. And that's why it's important to write it with the cubes, r squared plus s squared. Now here's where we have to be careful. When I get to my polynomial, I don't start with r squared. I start, class, with r squared squared, which is r to the 4th. Then r squared to the 1st, r squared. R squared to the 1st is r squared, and then r squared is gone. In the first term, it's not s I'm looking at, it's s squared. In my first term, s squared is gone. Then it's s squared to the 1st, which is s squared, and then in the back end, it's s squared squared, which is s to the 4th. What about my signs? Alternate. Positive understood, negative, positive. A little bit different. Same process though. Just looks a little different because we had powers raised to powers here. Just as here, we had a number raised to powers. Questions on that one? Still following? How about this one then? A to the 9th minus 125 b cubed. A to the 9th minus 125 b cubed. take the time, write it as something cubed minus or plus, in this case minus, something cubed. What goes in the first set of parentheses, Genesis? What is being cubed right here? Well, no, a is to the 9th. So what's being cubed? Audrey? A cubed, right? A cubed, when you raise the power to a power, multiply the exponents, right? So this must be a cubed that's being cubed, right? What about right here? 125b cubed. Well, obviously the b is being cubed. You can see it right there. What's being cubed to get the 125, anyone? 5. So this is really a 5b that is being cubed. Or sometimes students find it easier to cube them individually. 5 cubed, b cubed. Okay? Either way is fine. Well, in that case, class, we have a difference of cubes. And a difference of cubes factors into a binomial times a trinomial. Genesis, what's the binomial? Knock off the cubes. We'll knock off the cubes. 5b. There we go. A cubed is being cubed, 5 is being cubed, b is being cubed. So a cubed minus 5b. All right, in the parentheses, I start with my a cubed, and it's going to be squared. It's being cubed here, so we do 1 power less. It's going to be, in fact, if you wanted to write it this way, a cubed squared, a cubed to the first, a cubed gone, you could, right? And then you could have the 5b gone, 5 to the first, b to the first, 5 squared, b squared, if you wanted to. Does that make sense? And of course your signs, because you have a difference here, all positive. And then if you wanted to take a separate step and simplify, a cubed minus 5b, how would I simplify the polynomial here, Brandon?
A to the 5th.
Oh, careful, raise the power to a power, multiply.
A to the 6th. And then plus I. A to the 3rd plus a cubed b. And then positive 5b.
Well, 5 squared.
B squared.
So what is 5 squared?
25.
25. Okay, so a little more to keep track of when there's numbers involved, a little more to keep track of when there's other powers involved, but the process never changes. Questions here? Questions? One more to write down. A to the 4th, negative a. A to the 4th, negative a. On the surface, if I just cover this up, you assume we're going to do a difference of squares, right? Oh. What do we do? Thoughts?
A cubed.
What's the first thing we should always check for when we factor, class? Common factor. What's common? A. And if I pull out an A, what does it leave me with?
A cubed minus 1.
A cubed minus 1. And guess what 1 can be? Any power you want. In this case, 1 cubed. And now we have a difference of cubes after we pull out the common factor. Does that make sense? All right, so don't lose the common factor. Copy that down first. But the difference of cubes, class, factors into a binomial times a trinomial. The binomial is going to be what here, Maddie? A minus 1. Take a shot at the trinomial for me, if you would, Noah.
A squared. A and 1. Of 1. And then 1 squared. And all positive.
And what is 1 squared?
1.
And there we go. A squared, first, gone. 1 gone. 1 to the first. Really, we don't even have to write since it's got the A. And then 1 squared, or 1 we have to write there. Signs all positive. And there we go. Questions on this? Questions on this? All right, now I'm going to go back over here to that poster. And you may be thinking, Mr. Dasky, as we are working our way through the poster, common monomial factor, check. Perfect square trinomial, check. Difference of squares, check. Sum or difference of cubes. Sum or difference of cubes, it's not on there, is it? Because really, think about it, cubes are matching odd powers, but really a sum or difference of cubes is just a small subset of a larger factoring thing. Next section of your notes, sum or difference of the same odd powers. Sum or difference of the same odd powers. Pardon the poor theater there a moment ago. Sum or difference of the same odd powers. Now I want you to point out something interesting. For a sum or difference of cubes, we had a binomial times a trinomial. Well, cubes aren't the only odd powers. What's another odd power? Fifth power? Well, in that case, you're going to get a binomial and a 5-term polynomial. What if you had the 7th power? Binomial times a 7-term polynomial. So in general, sum or difference of the same odd powers, which would include sum or difference of cubes, gets you a binomial times a polynomial. We can take off the PST notation here since we won't necessarily be dealing with trinomials anymore. And the process is going to be exactly the same. The process is going to be exactly the same. Write this in your notes now. X to the 5th plus y to the 5th. Obviously, they're not cubes, but they are matching odd powers. And so, the same way we used division by inspection before, we can use this here. But instead of binomial trinomial class, we're going to get a binomial times a polynomial. How many terms in the polynomial? 5. So, give yourself a little extra room to fit 5 terms in there. Hope it's enough. All right, what's the binomial going to be, Audrey? X plus y. And what power will we start at in the polynomial class? X to the 4th. Then, and then we're going to start out with the y as being gone, then y, then, and my signs, because I have a sum right here, signs are going to alternate. Positive, negative, positive, negative, positive. By the way, one way I like to put it is things are never all positive. So if you have a negative here, the negativity is already taken care of. You can have all positives. If we have a positive here, we've got to alternate just to include some negativity, right? Maybe it's because I'm not an optimist. I don't know. Anyway, anyone in here, the glass is always half full? You're like, every situation you look at in life, hey, the glass is half full. Okay. Anyone say the glass is always half empty? Okay, that's a pessimist. I'm a realist. I say the glass is half empty and evaporating while we argue about it. So that's a realist. But anyway, yeah. So notice it's the same process as what we would have used for the sum difference of cubes. So is it a different thing altogether? Not really. Really, the cubes are just a special version of this. Does that make sense? Write this one down. You're going to love this one. M to the 7th minus 1. M to the 7th minus 1. M. Michael. Starts with M. All right, Michael. Same odd powers. I only see a single power. I don't see powers anywhere.
Yep. You get M minus 1.
Well, but we have to have matching powers to do this. Like here we have 5th and 5th. Here I got 7th and there's not even a power on the 1.
1 can be whatever power you want.
So write it as 1 to the
7th.
7th just for the fun. Okay, now we have matching odd powers. So now class, and then Michael will get back with us, we're going to factor this difference of same odd powers into a binomial times a polynomial. But how many terms in the polynomial? 7. Whatever the power is how many terms you're going to have. So, binomial times polynomial. Can't you imagine if you really ticked me off? M to the 13th minus, you know. Anyway, all right, so Michael, back to you. What's the binomial?
M minus 1.
That's the easy part, right? And really, this isn't hard. It just takes a minute and a lot of space on the chalkboard. Michael, what do I write for my polynomial?
M to the 6th plus M to the 5th.
Well, let's just go through the progression here instead of showing off and giving the whole answer. M to the 5th.
M to the 4th. M to the cubed. M squared. M gone.
And here's where, by the way, you're going to benefit from having a little line right here to remind you there's something that belongs there. All right, then as far as the 1, it starts out,
0.
well, gone, and then it's 1 to the first, which is 1, but I don't really have to write it, do I? Then 1 squared, which is still 1.
Cubed, 1 to the 4th, 1 5th, 1, and 1 to the 7th.
1 to the, you went from 5th to 7th. 1 to the 6th, which is
1.
Still 1, either way, right? And my signs are going to be
Positive.
all positive. Again, if this were anything but 1, if this were a 2 to the 7th class, right? If it were 2, 4, 6, or 2, 4, 8, 16, 32, 64, and so forth, right? Taking your powers of 2. 1, fortunately, to any power is still just 1. But good. Questions on this? Do you see the pattern? And that's why I wanted to teach you the division by inspection, so that the pattern makes sense to you here. One more, and then we'll have to be done. A to the 5th minus 32. Thoughts on how we could rewrite this raise of hands? Noah? Good, a to the 5th minus 2 to the 5th. So Noah, we have same odd powers. We're going to factor this into a binomial times polynomial. Binomial's 2 terms. Polynomial here is going to be 5 terms. We're going to start with our binomial, Noah. And then the polynomial. Here we go.
A to the 4th, A cubed, A squared, A, and gone.
All right.
And gone, 2, 4,
2 squared.
and 8,
2 cubed.
and 16.
2 to the 4th. So we're ending 1 power less than the 5th power, 2 to the 4th. And signs?
All positive.
Once again, all positive. And there you go. Do we feel like we got it now? You're going to practice in the homework. Do we feel like, yeah, I think I got this? All right, homework for this evening. Homework for this evening is to do page 28. Page 28, numbers 13 through 40, the teal. Okay, page 28, numbers 13 through 40, just the teal problems. And numbers 43 to 53, just the odd problems. 43 to 53, just the odd problems. There's one extra credit for you, and it's number 42. And number 42 will be extra credit if you'd like to try that. All right, you are dismissed. Have a wonderful rest of your day, and we'll see you next time.